All right, we're going to take another look at perimeter of these composite shapes as well as finding the area of these composite shapes. So first we're going to start with the perimeter. For this, I'm going to be highlighting my vertical measures in one direction and my horizontal measures in another direction. So I'm going to do, for all three of these first problems, highlighting my vertical measures in pink. And this one down here, vertical, vertical, vertical. Then my horizontal measures in blue. Okay. For this, for number one, my X is in blue. So I'm going to be looking at my blue values, which means my Y is in pink, and I'll look at pink for Y. So looking at X, the three blue values, we have X, we have 12, we have 18. Between these three sides, X is not the longest side, so we're going to subtract. So we're going to take our longest side of 18 minus the other side of 12. 18 minus 12 is 6 meters. For my Y was in pink. So I'm going to look at the pink values. I've got a 9 over here. I've got a 20 over here. Between these three vertical pink measures, Y is not the longest side. This is the longest side. So we're going to have to subtract. We're going to take that longest side of 20 minus the other side of 9. 20 minus 9 is 11 meters. Looking at number 2. My X this time is in pink, so I'm going to be looking at the pink values for X. My Y is in blue, so I'm going to be looking at the blue values for Y. So for X, I'm looking at these three pink values. Of the three, X is not the longest side, so I know I'm going to subtract. I'm going to take the longest pink side of 25 minus the other pink side of 16. 25 minus 16 is 9 centimeters. Okay, for Y, we are looking at these three horizontal measures. So of these three, Y is the longest side of the three. So we're actually going to add the other two values. So I'm going to do 14 plus 20 equals 34 centimeters for that length. Let's practice one more where we're finding those missing measures before we get into the composite area. So here our X is in pink. So we're going to look at the pink values for X. Our Y is in blue. So we're going to look at the blue values for Y. So for X, I'm looking at these three measures. X is not the longest side, so we're going to subtract. We're going to take our longest side here of 50 minus the other side of 19. 50 minus 19 is 31 meters. Looking at Y is in blue, so we're looking at these three blue values. Y is the longest side, so we're going to add those other two values. 23 plus 34 is equal to 57 meters. So this is a little intro. We're going to have to use that skill when we are doing these composite shapes, okay? So for this example, number 4, you'll notice I have the same picture twice because I'm going to show you how there's two ways to go about solving it. And sometimes there's going to be an easier way and a more complicated way. So one way would be to divide our rectangle vertically. So when I do that, I have a rectangle right here, which I'm going to find the area of, and then I have a rectangle here. So looking at this, we're trying to find the base and height. Well, this measure isn't here, but on the opposite side we have 7. So that tells me I have a base of 7 times, I don't see a vertical height right here, but I do see it there. So 7 times a height of 4 gives us an area for that first rectangle of 28. Now we're looking at this second rectangle. I don't see a measure right here, On the opposite side, it's 3, which means it's the same on the bottom. I do see my height right there of 8. So we're going to do our base of 3 times our height of 8 to get an area of 24. And I would add those two together. 28 plus 24 is equal to 52. And we're talking about area, so centimeters squared. Now let's look at the same shape. Instead of dividing it vertically, we're going to divide it horizontally. And sometimes they are both equally easy or difficult, but sometimes one option is a little bit harder than the other. So here we have this bottom rectangle here. And we have this top rectangle. So for this pink rectangle first, we don't have a measure right here. If I look on the opposite side, that 7 is only talking about the distance here. It's not giving us the entire length. So what that tells me is that this is 7. This part right here is going to be the same as the opposite of 3. So we would have to add those two together to get that this distance across is 10. Where sometimes people will make a mistake then is they'll look at this and they'll say, oh, 8, that's the height right here. 8 is not the height of this portion. 8 is the entire length. So I don't want to look here. I look on the opposite side and I would see 4. So I would do 10 times 4 is equal to 40. Up top here, I don't see a measure right here. On the opposite side, it's 3, which tells me this portion right here is 3, which we kind of already included down here. On the right side, again, this entire measure is 8, not just this portion right here. So I would have to look and say, well, if that opposite side is 4, that tells me this little pink portion is 4. If the whole side is 8, 8 minus 4 tells me that this portion right here is 4. So I would do 3 times 4 equals 12, and I would add those together and I would get the same area. But here's the thing. This first option required less work because the way that I divided it, this had the dimensions already for it, this had the dimensions already for it. Versus here, we had to do some addition or subtraction, which in my opinion is more work. I'd rather not do it this way. So if you start this way and you're noticing it's a lot of work, I would go back and try it the other way. Sometimes you have to do this, but sometimes if you rework it and do a different split, it might make it easier. So let's look at this again. Same thing, we're given 2 of the same option. So I'm gonna show it dividing it both ways. First, I'm gonna divide it vertically, then I'm gonna divide it horizontally. So here I have it split vertically. I have my rectangle here. And I have my rectangle here. So for finding the area of the rectangle, if we look at this one, we have the base of 8 times our height. We don't have a measure on the right side, but if I look on the left side, I see that entire height of 15. So I do 8 times 15, which is 120. Now I'm gonna look at the blue. I don't see a measure on the bottom for our base. If I look on the opposite side, a lot of people think 20, but 20 is talking about the entire distance, including this pink portion for the other rectangle. We want just this portion. So we gotta go back and think, okay, if this pink portion doesn't say anything, on the bottom it says 8, which means this top is 8. So if the entire length is 20, 20 minus 8 leaves us with 12 for this portion right here. And then the height, we have a 4. So we would do 12 times 4 is 48. We add those two together, we get 168. The units are feet squared. So that was dividing vertically. We did have to do some work. Let's see if when we divide it horizontally, if it would be any easier. So I'm gonna divide it this way. I've got a bottom rectangle right here. And a top rectangle right here. Let's look at the pink one first. So for the pink one, we have this base measure of 8 times, there's no measure right here for the height, so I look on the opposite side. My instinct is to say 15, but 15 is talking about the whole distance. So I got to figure out this blue portion. Well, if this blue portion doesn't have anything, I look on the opposite side, it's 4, which tells me this part is 4. So we would do 15 minus 4, which leaves us with 11 right here. So I would do 8 times 11, which is 88. Now I'm looking at our blue. There's nothing listed right here, but on the opposite side it says 20. So this entire length is 20 times this height of 4. We get 80. We add those two together, and we get the same exact area. So in this instance, unlike the previous one, really either option really wasn't better. We had to subtract here, we had to subtract here. So if you tried this and are like, let me rework it, you'd be in the same situation. You have to do some subtraction. Now let's look at the last one. Again, I'm gonna start by splitting it vertically. So I split it vertically. I'm gonna highlight my first rectangle, and then I'm going to highlight my second rectangle. So, looking at the pink rectangle. If I look at the base here, don't get confused by 14. 14 is talking about the entire length. So I'm gonna go to the opposite side. This pink portion is 9, which tells me the pink portion on the bottom is 9. For our height, there's nothing listed right here on the right side, so I'm gonna look on the left side. I see that the entire length is 12. So we're gonna do 9 times 12 is 108. Then I'm gonna look at the blue portion. Again, 14 isn't talking about this, that's talking about the whole entire length. So if there's nothing listed on the bottom, I'm gonna look on the top, it says 5. So that distance across is 5, our height is 7. So we're doing 5 times 7, which is 35. We add those together, I get 143 meters squared. So that one we didn't have to do any adding or subtracting, I just had to make sure I'm looking at the right spots. Let's see if we had split it horizontally, if we would have that. I'm gonna highlight this bottom rectangle in one color, and this top rectangle in another color. Okay, for the first rectangle, I have a base right here of 14 going the whole way across, times this height right here of 7. 14 times 7 is 98. Now looking for the blue. I don't see anything on the bottom, so I look on the top. It tells us 9, so that tells me this part right here is 9. For this height, we don't have a measure because this 5 is talking about this portion. So I look on the opposite side. Don't get confused by 12. 12 is talking about the entire length. So we have to figure out this pink portion on the opposite side is 7. So that's 7. So we have to do 12 minus 7 gives us that this height is 5. So we would do our base of 9 times our height of 5 is equal to 45. Add those two together, you get 143 meters squared. We got the same answer. This first option was easier because we didn't have to do any adding or subtracting. Over here, we did.